Here we go. Suppose some tiny tropical fish are introduced into a large aquarium and the population grows at 7% annually. A few years later, the kid responsible for feeding them notices that the population is not growing as fast as it used to. Assume the maximum sustainable population is around 600 fish. So this is one of those huge aquariums where they have a bunch of different fish in there, and they just kind of let it be its own ecosystem, and it grows. And he sees it boom at first, and then the growth rate starts to slow down because that big of an aquarium can only sustain 600 fish. Okay? If there are currently 400 fish in the tank, use the model to predict next year's population. So I don't know how long these fish have been in the tank, okay? But we currently have 400 fish in the tank. How many do he think are going to be in there next year? So we're going to plug it in. This is actually, with all of this confusion, the homework for this is easy. Plug it in. P of n, okay? So next year, currently there are 400 plus, okay? It was growing at 7%, but we need to limit it, right? We need to limit the growth rate. So 1 minus where we're at now times the carrying capacity times where we're at now. You just plug those numbers in. And we'd say, you know what, next year there's going to be about 409.3 fish. Literally, you're plugging in the now population, the rate they gave you, and the carrying capacity, and push enter on your calculator. Okay? Says, now what is the current growth rate? Well, it was originally growing at 7%, but how quickly is it growing now that we're at 400? And my guess is it's going to be we're going to lose about 2/3 of it because this is 2/3 of the 600. Okay, so let's look. We plug it in to this formula. We were at 7%. 1 minus 400 over 600, we are only growing now at 2.3%. Yeah, we lost 2/3 of our growth rate because we're 2/3 of the way full. Does that make sense? This is 2/3. 1 minus 2/3 meaning we're only keeping 1/3 of the 7% because we have 1/3 left. All right. What do you expect to happen to rate of growth as population grows? In general, guys, what's going to happen to this rate of growth as the population gets closer to 600? As the population reaches the carrying capacity, the growth rate goes to 0. That's that triangle graph on the previous page. Okay. So, suppose the world human population has a base growth rate of roughly 2.8% and the Earth has a carrying capacity of around 12 billion. Okay? Estimate the growth rate in 1960 when the human world population was 3 billion. I want you guys to try that. Plug them in. So we have an R of 2.8, okay, a K of 12, okay, and our current population right now, or in 1960, was 3 billion. Plug and chug. So here's what you should have plugged in. Okay, our current population, our carrying capacity, and our current rate. Now, could you type in 3 billion with all the zeros? Yeah. Yes. Okay. Do you need to? This one's going to have as many zeros as this one because it's billion. So 3 billion over 12 billion is going to be the same ratio as 3 over 12. So you could have just done 0.028 times 1 minus 3 over 12, okay? And it's growing at a rate of 0.021. Okay, estimate the growth rate in 1985 as we now have more people. Same thing, and the rate went down. Yes?
So when the problem says like as a base rate of growth, like roughly 2.8%, is that assuming the population is at like 1 or 2?
It's, yeah, at whatever it's starting at. Or wherever they decided to take the measurement, and in this case we don't know nor do we care. Okay. And predict the rate of growth today when there are 7.4 billion. Notice that it continues to get slower. Now, is it really going to be this type of rate? What are some factors now that might make this even lower or higher?
Advanced what?
Advanced medical technology. Okay, more people are going to live, which means they're going to live to reproduction age. What else? Wars, okay, absolutely. World War I, World War II, wiped out a bunch of the men that could have been there reproducing. What else? Diseases, what else?
Mormons.
Okay.
Countries reaching like further development.
So basically we're highly developed, so we've got more food, more resources, but also, when did people start reproducing now? Later. Okay, it used to be you graduated from high school, you got married, you started popping out kids. Okay, Utah has a lower rate, a lower age for when you start creating families, but overall in at least our nation, the rate has gone up, or the age has gone up. Okay, people aren't starting to do families till their late 20s, early 30s, even their late 30s after they've done their graduate degrees. So first off, less years to reproduce, and also you are less fertile when you're older. They are not having as big of families. So there's all these confounding variables that have an effect on this as well. It's not going to be, this is just an estimate. Does that make sense? There's all these other things going on. All right, last but not least, almost. Compare your calculations to the graph from worldometers.info. So, this is the graph, okay? Our first one at 0.021, this is where we thought our growth rate would be, and it was lower, right? This was our initial growth rate right here, which is pretty close to the worldometer. We probably had us start right here. But then when we calculated the first one, ours was high, okay? When we calculated our one from 1985, it was low. So again, it's still following the trend, and then we calculated the one from now, we're even lower than they said. So is our prediction okay? Yeah, we started high, we got low, and then we got lower. We followed their trend, but we still weren't accurate to what was really going on in the real world because of all those other confounding things. All right. Is it reasonable to predict world human population using a logistic model? So, right? It was still way better than what we did here using exponential. We were way off. It is better, but it is not perfect. Better than the exponential. Anybody ever seen the PERT equation? You seen one of your other classes? This one is even better. Okay, initial population, e to the rate times time. This is the one, or the base one, that scientists tend to use. They use logistics, but this is also a really common one. And you'll find it later. We won't use it in this class, although it's very close to what we've done. All right, what factors affecting world humans are contributing to the trend you see above? More people, less food, space, pollution, lack of natural resources, disease, lifestyle. And what I mean by trend is it was going down. We are reaching our carrying capacity. Okay. That's it. You now know enough to do all of this module. Congratulations.